Good day all, and you're welcome to today's class. So today we'll be doing studying section 6 unit 2, which is test of hypothesis. Last time we talked about estimation. We talked about the type of estimator. We have point and interval estimator. We talked about when to use standard normal distribution and when to use t-test, student t-test. We say when our sample n is less than 30, we use t-test. When it is greater than 30, we use standard normal distribution. And we give various formulas for calculating mean, the mean and proportion, estimating mean and proportion. So today we are going to study test of hypothesis. What are the objectives of this study unit? The objectives of this study units are to enable students to one, to understand the concept of a statistical hypothesis and its roles in statistical inference. 2, learn and apply the key definition in hypothesis testing, which includes the null hypothesis, alternative hypothesis, level of significance, type 1 and type 2 error. Another objective is to recognize the structure of a statistical testing, including test statistics, what we mean by critical region and decision rule. Conduct hypothesis tests about a single population parameter, mean or proportion, because last time when we are discussing about estimation, we talk about mean and proportion. So using appropriate method. Distinguished between one-tailed and two-tailed hypothesis test and interpret their results. Relate the concept of p-value to hypothesis testing decision. Study the importance of hypothesis testing in solving real-life problems in business, economics, and social science. The learning outcome for study section 6 unit 1. By the end of this unit, students should be able to define and explain the concept of hypothesis testing, statistical hypothesis, state the difference between the null hypothesis, which is our H0, and alternative hypothesis, which is our H1. Identify and explain what we mean by type 1 error, type 2 error, level of significance and power of a test. Describe the structure of a statistical test, including formulation. How do we formulate a statistical test? The test statistics that we are using, the decision rule, our decision based on our result and conclusion. Perform hypothesis tests about a single population mean when the population variance is known or unknown using appropriate formula. We know the other time when we are talking about estimation, we say that we use statistics, so t-test when the population variance is unknown, and we use standard normal when the population variance is unknown and when our n, which is our sample, is less than 30. I think I emphasize on it in study section 6 unit 1. Also, distinguish between interpret p-values and use them to make test decision, one-tailed, two-tailed test, and apply them correctly. Interpret p-values and use them to make testing decision. Then apply hypothesis testing to solve real-life problems in business, in economics, and social science. Introduction. In statistical inference, we often want to make decision about a population based on the information that we observed from the sample. That is what we do in statistical inference. We often want to make decision based on about the population. We want to make a decision about the whole population based on information we obtain from the sample. You know, I think the last class I talked about what we mean by a sample. When we take a proportion or portion, or when we take a portion from the whole population. So from the sample that we obtained, or when we take it from the sample that we took, when we want to make decision about the whole population based on the information that we obtain from the sample, that is what statistical inference is all about. Hypothesis testing complements estimation. Hypothesis testing complements estimation by providing a structured frame to work to make decision about population parameter based on sample evidence. Hypothesis, what is it all about? Hypothesis testing complements estimation. We've talked about estimation the last class. How does it complement estimation? It provides a structured framework to make decision about population parameter based on sample evidence. I think the other time we talked about the population parameter, which are the mean or mu, the variance. I think we talked about it the other class. So for example, we might test whether the average income in a city has increased or whether a new teaching method leads to better exam scores. For example, a manufacturer may want to test whether the average lifetime of a new battery is greater than 500 hours. Or a university may want to know whether the proportion of students who pass an exam is at least 70%. To answer such question, we use hypothesis testing. Estimation and hypothesis testing are foundational concepts in statistics and are widely used in economics. We use it in business, in social sciences, we use it in medicine, in engineering, and also they form the basic for informed decision under uncertainty. Now, we really know the true population parameter. You know, the other time I said the true population parameter. The population parameter are the mean, the mu, sigma square or proportion. The mean, which is also called the mu, variance, which is the sigma square or proportion p. Instead, we collect data from a sample and use it to make inference about the population. Statistical hypothesis. What is statistical hypothesis? Statistical hypothesis is a statement about the population parameter. This is a statistical statement which may or may not be true concerning one or more population. Let me emphasize more on this. Statistical hypothesis. Statistical hypothesis is a statement about the population parameter. This is a statistical statement which may or may not be true concerning one or more population. It is a claim or assumption that a population parameter such as our mean, our variance, our proportion. It is a claim or it is an assumption about the population parameter. You know, I've once said that the population parameter includes the mean, the variance, or proportion. Hypothesis testing. Hypothesis testing provides a formal procedure for deciding whether sample data provide enough evidence to either support or reject such claims. And there are two types of statistical hypothesis, which are, we have the null or true hypothesis or the alternative hypothesis or the alternate hypothesis. So let's first discuss about the null or true hypothesis. The null hypothesis is a statement of nature about the population parameter. What nature says about the population parameter, the actual nature, normal thing, nature, like it will rain today. Maybe we are in the rainy season. Nature, you've already know that it will rain today. So null or true hypothesis is is a statement of nature about the population parameter. This is an assertion that the parameter in a statistical models take a particular value. Example, this hypothesis also expresses no difference between the observed value and the hypothesis value. It is denoted by H naught. Our null or true hypothesis is denoted by H naught, and we can give that H naught given theta 1 is equal to theta naught, where theta is the observed value and theta 1 is the true value. Then alternative hypothesis, which is our H1. This hypothesis express a deviation in the null hypothesis. That is a shift or a deviation in the null hypothesis. It states that the true value deviates from the observed value, and it is denoted by H1. So if we want to set our hypothesis, we say our null hypothesis H naught given theta 1 is equal to theta, while our alternate hypothesis is H1 given theta 1 is not equal to theta naught, or it can be not equal to, it can be greater than, that is theta naught is theta 1 is greater than theta, or it can also be less than. Alternative hypothesis is a statement that contradicts H naught. That is what alternative hypothesis do. It always contradicts H naught. It represents the researcher's claim. The alternative hypothesis represents the researcher's claim. For example, if they are given that our H naught given mu is not equals to 100, that is an alternative hypothesis. So it represents the researcher's claim. Example, given that H1 is not equals to mu, H1 given mu is not equals to 100. Our true or null hypothesis can be H naught given mu is equals to 100, and our alternative hypothesis or the researcher claim may be H naught given mu is not equals to 100. Also, in hypothesis testing or statistical inference, we have some definition. One, the first one is the test statistics. The test statistics, the calculated quantity from the given information, which when compared with the tabulated value to take a decision about the hypothesis is being tested. A standardized value calculated from sample data can be used to decide between H naught and H1. The choice of appropriate test depends on the type of estimate and the sample distribution. The choice of test that we want to use in statistical inferences depends on the type of estimate and the sample distribution, that is the distribution of the sample we are using. Then we have critical region. Critical region is the set of all values whose probability is small on the null hypothesis, which is better explained by alternative hypothesis. Also, we have the significance level. It is the probability of taking a wrong decision or the probability of making error. For everything we do in life, we should always give little percentage of error. Nobody is perfect except God. So the significance level is the probability of taking a wrong decision or the probability of making error. That is the probability of rejecting the true null hypothesis, which is our type 1 error. There are two types of error in hypothesis testing. We have our type 1 error and type 2 error. What is type 1 error? Type 1 error is the error of rejecting the null hypothesis, that is the true hypothesis, when it should be accepted. Type 1 error. Type 1 error is the error of rejecting the true or the null hypothesis when it should be accepted, and it is denoted by alpha, which ranges 0 less than alpha less than 1. Alpha will now be probability of rejecting our H naught, and when our H naught is true, when it is supposed to be accepted, that is type 1 error. Let me repeat myself again. Probability of rejecting H naught, that is the null hypothesis when it should be accepted. That is when probability of rejecting H naught, which is equals to H naught is true. Then we have the type 2 error. This occurs when H naught is accepted or when we do not reject H naught when it is false. H naught is not true, but we do not reject it, instead we accept it. This probability is denoted by beta. It is denoted by beta. So 1 minus beta equals to probability of rejecting H naught given H naught is false. Then we have our table. Accept H naught. H naught is true, 1 minus alpha. When H naught is false, beta. Reject H naught, alpha. Then 1 minus beta when H naught is false. The power of a test. Probability of correctly rejecting a false null hypothesis. That is the definition of the power of a test. The power of a test is the probability of correctly rejecting a false null hypothesis. Then let's go to the structure of a test. A statistical test of hypothesis may be structured as either one-tail or two-tail test. For a one-tail test, we have our H naught given our mu equals to mu naught, and our H1. Our H naught is our true or null hypothesis, while our H1 is our alternative hypothesis. So our H1 given our mu, the other time I said our H0 is the true or null hypothesis, which is the nature. So H0 given mu equals to mu naught. Therefore our H1 will either be H1 given mu is not equals to mu naught, or mu is greater than mu naught, or mu is less than mu naught. We also have for a two-tailed test. In this case, the alternative test is not well defined for two-tailed test. Example: a researcher is interested in the mean level of some enzymes in a certain population. The data available to the researchers are the enzymes determination made on a sample of 10 individuals from the population. Made on a sample came from a population that is normally distributed with our variance, which is our sigma, to be 45. Can the researcher conclude that mean enzymes level in the population is different from 25? The first thing, when we are conducting statistical hypothesis, first thing we do is we set our hypothesis. When we are conducting statistical tests, we set our hypothesis. Our hypothesis is H0 given mu naught is equals to 25, because from our questions, H0 given, what they asked us to do is that, can the researcher conclude that the mean enzymes in the population is different from 25? So our H0 given mu naught is 25, and our H1 is not 25, and our H1 is mu naught. H1 given mu naught is 25. Then our alpha, that's our level of significance, is 0.05. Our n here is 10. Our x bar is 22, and our alpha over 2 is 0.05 divided by 2, which will give us 0.025. Our test statistics, we are using standard normal. So using the formula x bar minus mu over sigma, square root of sigma over root n. What is our x bar? From here our x bar is 22 minus, what is our mu? Our mu is 25. Then our sigma, our known variance. I told us when our variance is known, we use the standard normal distribution, which is 45. Then our n is 10. So when you do your estimate it, it should give you minus 1.4142. From the normal distribution table, z of 0.025 gives us 1.96. That is how we get our table value. Decision: since z equals to minus 1, we compare our calculated value, which is minus 1.4142, with our table value, which is 1.96. So our decision is reject H0 if z calculated is greater than z tabulated. From here we can see that our z calculated is less than z tabulated, or z, the value from our z table. Therefore we accept H0, because from here our minus 1.4142 is less than 1.96. Therefore we accept H0. Then we conclude, based on our decision, since we are accepting H0 and we've set our H0, we conclude that the researcher can conclude that the mean enzyme in the population is not different from 25. It's not different from 25. So when sigma is unknown, the other time when we are talking about estimation, I said when sigma is unknown, we use t-test. The same thing applies here. A certain drug company claims that one brand of headache tablet is capable of curing headache in 1 hour. A random variable of 16 headache patients is given the tablet. The mean curing time was found to be 1 hour and 9 minutes, while the standard deviation of the 16 time was 8 minutes. Does the data support the company claims or not at 95% level of significance. That is our alpha. We set our hypothesis. H1, H0 given mu naught is equal to 100, which is our null hypothesis, and H1 given mu naught is not equal to 100, which is our alternative hypothesis. Which the alternative hypothesis is the researcher's claim. Then, since we are using t-test, we apply the formula x bar minus mu naught all over s over root n, which is equal to 1.15 minus 1.0 over 0.13 all over root of 16. When you do our calculation, we get 4.6154. Then we get our table value from t. This time, instead of using standard normal table, we are using t. So from here, we take our decision. Since t calculated, which is 4.6154, is greater than t table, that we check that from our table. From our t table, 0.025 alpha at n, when our n is equal to 15, we get 2.13. Then we reject h naught and conclude that the data does not support the accompanying chains. Hypothesis testing. The difference between two populations. Variance known. We use this formula. X bar 1 minus x bar 2. That means we will be given 2x, x1 and x2, 2 mu, 2 sigma, and 2 n. So the test statistics, z equals x bar 1, that is between two populations. The other one we talked about the other time is between one population, but here is between two populations. X bar 1 minus x bar 2 minus into bracket mu 1 minus mu 2 over root of sigma 1 square over n1 plus sigma 2 square over n2. We set our hypothesis. Mu h naught given mu 1 is equal to mu naught to mu, because we are having 2 mu equals 0, versus h1 given mu 1 minus mu 2 is not equals to 0. Then we use our test statistics, which is our z, the formula. The difference between two population mean variance unknown but assumed equal. We use this formula. Then what is our one is when variance is known, the other one is when variance is unknown but we assumed equal. That is when we use this formula. Then we check our calculated value. Using to get our x calculated value, we use n minus 1 s square over sigma square. In the other formula, we are giving in sigma square, but here we are giving in s p square. One is in variance while one is in standard. Thanks.